Okay, for question number two, uh, there's a function that's defined from set of all r plus is the set of all non-negative real numbers, and it's defined from this set to set which contains the real numbers from -5 to infinity. So, and the function is this 9x squared plus 6x minus 5. We have to check whether it's 1, 1 onto bijective, either 1, 1 or onto. So let's try to understand the question first. This is the domain, and domain consists of all positive real number, that is non-negative real numbers, and the codomain, that is the value of y, this is the value of x, and this is our output. It contains, this is the set from minus 5 is 100 to infinity. Okay, and this function is defined as f of x is equal to 9x squared plus 6x minus 5. We have to check whether it's 1, 1 or onto. Okay, so 1, 1 or onto, what we will do, we will consider two elements that belongs to the domain, so that x1 and x2 belongs to the set of all negative non-negative real numbers, and let their respective images be fx1 and fx2. Now let's assume that these both two images are same, and we know that the function is 1 1 as well when for every x there is a unique y, for every element x there is a unique image. So if we are considering that these two images are same, then these two should not be different, these two should also be the same. That is, for only one element there is a unique image. So let's put in the value of x1 1. According to this function, the value of f of x1 is, this is 9x1 square plus 6x1 minus 5 is equal to 9x2 square plus 6x2 minus 5. Okay, so -5 and -5 plus cancel. And let me arrange or try to get this solved. So 9x square, this is minus 9x2 square plus 6x1 minus 6x2 is equal to 0. And for these, the common is 9x1 square minus x2 square, and for these common is 6. So x1 minus x2 is equal to 0. Then a square minus b square, which gives me 9a, let it be, plus b into a minus b plus 6 into x1 minus x2 is equal to 0. Now for these two terms, our common factors are 3 x1 minus x2, and now we are left with, this is 3 x1 plus x2 plus 2 is equal to, okay, so which gives me, actually this should, okay, now out of these two factors, either 3x1 minus x2 is equal to 0, or 3 into x1 plus x2 plus 2 is equal to 0. But this cannot be 0 because x1 and x2, these are both the belong to the set of non-negative real numbers. That means this is positive, this is positive, this is positive, this is positive. So this cannot be 0. And now this, we are left with this, which gives me x1 minus x2 is equal to 0. So therefore x1 is equal to x2. That means if two images are equal for two different values of x, then these two are also not different. These two are also the same values. These two are also equal, which gives me that the given function f is 1, 1. Now let's check this function for onto, if it's onto or not. And for onto, our function is, so how do we say that a function is onto? And to define function, or a function is onto, when for every y that belongs to the set, there exists x that belongs to the domain, so that f of x is equal to y. So for onto our function, it goes from all set of positive real numbers to -5 to infinity. Okay, now, and f of x, our function is defined as this is 9x squared plus 6x minus 5. So when will this function be onto? So this function is onto. So we can say that the function is onto when for every for every y that belongs to -5 to infinity, that is the codomain, there exists x, and x should be, and it should be such that f of x should be equal to y. Okay, so let's try to check whether it's onto or not. Let's try to check that for every value that is in codomain, there should be an x. Okay, now our function is f of x is equal to 9x squared minus 6x plus 5. This is our function. 9x squared, sorry, this is 9x squared plus 6x, and this is negative 5. And f of x means this is y, so y is equal to, so this is a quadratic equation. Let's try to get it into uh, some known form, a minus b or a plus b the whole square. So I'm going to take 9 common, so we are left with x squared, and this is 6 by 9x minus 5 by 9. So this is 3 to the 6, 3. So finally we have y is equal to 9. This is x squared plus 2 by 3x minus 5 by 9. Okay, 9. So we are going to change this into a plus b the whole square. So x squared plus half of this. So half of this is 1 by 3. So I'm going to add, so this is 2 by 3x minus 5 by 9. So I'm going to add 1 by 3 the whole square and subtract it in this. So y is 9 y. So this is now a square plus b square plus 2 into a. So this is a square 2 into a into b plus this is b square, and we are left with this is negative 5 by 9 and minus 5 by 9. Okay, now which gives me 9. This is now a square plus b square plus 2ab. So this is a plus b the whole square, and this is minus 6 by 9, which is 2 by 3. Okay, so now finally I can write y as, so y is equal to x plus 3 the whole square, and okay, so this is 9 into x plus 1 by 3 the whole square minus 2 by 3. And let's multiply all these with 9. So which gives me 9 into x plus 1 by 3 the whole square, and 9 into minus 2 by 3. So which is 6. So this is minus 6. And how this is. Okay. So finally we have y, and I can write it as, so this is 9, and this can be written as 3 square in x plus 1 by 3 the whole square. So this is 3 into x plus 1 by 3 the whole square minus 6. And finally I have got it reduced to, so let's multiply this. So 3 into 3x, so 3x plus 1 the whole square minus 6. This is y. And let's take 6 to the left hand side. So this is y plus 6 is equal to 3x plus 1 the whole square. We are going to get the value of x. So 3x plus 1 is equal to under root y plus 6. This is plus minus, which gives me 3x. So 3x is equal to, this is minus 1 plus minus root of y plus 6. And I can write x is equal to minus 1 plus minus root of y plus 6 by 3. So finally, I've got the value of y. Now, uh, we are going to prove that when x belongs to all non-negative real numbers, okay, now here we have x that belongs to all non-negative real numbers, and here y, we are given that y belongs to minus 5 to infinity. That means y is greater than equal to negative 5. So y is greater than equal to negative 5. Okay. Now y is greater than equal to negative 5. I'm going to add 6 on both the sides. So which gives me y plus 6 is greater than equal to negative 5 plus 6. And this is now equal to y plus 6 is greater than equal to 1. Let's square root on both the sides. So square it on both the sides will give me, this is root of y plus 6 is greater than equal to the root of 1, which is 1. And let me add negative 1 on both the sides. So this is negative 1 plus y of 6 is greater than equal to root of 1 is 1, and negative 1, which will give me 0. And I'm going to divide this with 3 as well. So this is now equal to negative 1 plus root of y plus 6 upon 3 is greater than equal to, this is 0. So 0 by 3 is 0. So this is 0. So that, and this value is our x. X is greater than equal to 0. So that means for every y, so if for every y that was greater than equal to minus 5, we have x which is greater than equal to 0, and this x is greater than equal to 0 means that this belongs to all non-negative real numbers. So for every y that belongs to minus 5 to infinity, there exists x that belongs to, so we can say that for every y that belongs to minus 5 to infinity, there exists x that belongs to non-negative real numbers such that f of x is equal to 9x squared plus 6x minus 5. So our function is on, and as function is 1 1 and on 2. So when the function is 1 1 and on 2, that means that the function is bijective. So this function is bijective. So the function which is 1 1 and on 2 is bijective, and our option should be option C. Let's move on to the next question.